Welcome everybody to the next video in our series on computer programming for mathematics. I am Dr. Lathram, and today we will be discussing loops and conditional statements. Now, all that a loop is, it's just a simple segment of code which is going to be repeated more than one time. So when we're in Python, then a loop can be done over any iterable object. So anything such as a string or a list, a tuple, or a dictionary. All of those are iterable, and we can loop over all of them. The syntax for Python is pretty straightforward. We have for, so saying this is where we're going to start our loop. So for, then we give it the name of the index variable that we want to use for the loop. So for index variable in, and then whatever object it is that we are going to iterate over. Then to start the loop, we are putting a colon here. Then all of the commands that we want to execute inside that loop, we put after the for, but so that Python knows that these are supposed to be included in the loop, we have to put an indent. So we put some space over from that particular column. How much space doesn't necessarily matter, as long as Python sees space there so that it knows the next command is included in the loop. As soon as we put a command outside, so we move it back and we don't have an indent anymore, then that's going to be the first command that's going to be outside the loop. So the colon is there to let Python know that we're starting the loop. The commands inside the loop are all indented, and the first command that's outside the loop that's not indented is not considered part of the loop itself. Now let's kind of demonstrate this with an actual concrete example. So let's begin by saying that we want to define some objects, some iterable objects. And so let's say we want to define our objects. So we'll comment that, and then let's say that we have my string, which will just be, how about A, B, C, D, E, F, G, 1, 2, 3. Okay, so that's my string. I can do my list as being, how about the letter A, the number 1, and the number 3.14. So we've got a character, we've got an integer, and then we've got a floating point number. How about my tuple? Kind of being the same thing, except we'll have, let's change the order on that one. Let's do 3.14, A, and 1. Okay, so that's my tuple. And then finally, let's do a dictionary. So my dictionary being, how about the first key, K1 being, let's see, we haven't had one first. Let's do K2 being our 3.14, and our third key, K3, let's make him, what are we missing? The character A. Okay, so we've got my string, my list, my tuple, and my dictionary. Now, when we actually go through and iterate through this list, well, let's just have it do something kind of simple. So we can say, remember our syntax is going to be, so for the entry in, and now whatever object we happen to be iterating over. So how about for entry in my string? Okay, so for every entry in my string, let's just print the entry. Okay, so that's something kind of simple and easy to do. So if we save that, so we go up here, file, and save that, then we can run it. And again, kind of a shortcut thing that we could do, we could either go up to the menu and hit run and then run the module, or we can just hit F5. So if we hit F5, then what happens? we see the output over here, and sure enough, it's running our loop example, and we have A, B, C, D, E, F, G, 1, 2, and 3. And so sure enough, it's iterating over our loop for over our string. Well, what if we didn't want to iterate over the string? So what if we wanted for entry in my list? So how would that go? Well, we just change the object that we're iterating over, and let's do the same thing, print entry. So now, so that we don't go through the first one again, let's comment that out. And so now let's see what happens. When we hit F5, we run it, and we get our first entry, our second entry, and our third entry in our list. Okay. Well, now let's do the same thing for the my tuple. Okay, so let's comment that out. And for my tuple, so for entry in my tuple, syntax is pretty much the same. Print the entry. Save it and run it, F5, and we get our tuple values printed out. And now for the last one, let's go over the dictionary. Now the dictionary is somewhat different in that it is an iterable object, but we're kind of not necessarily iterating over we may not want to iterate over the dictionary itself, but we can iterate over the keys in our dictionary. So let's save that and see how that might work. So for our key in my dictionary.keys, so my dictionary.keys, is actually going to be a list, so we're iterating over that list. And then we want to maybe print out my dictionary and whatever the key value is for that particular one. And so that one's maybe just a little bit different, but the idea is still basically the same. You have your variable for your that you're looping over, and then the object. So the list of objects, or the collection of objects that you want that index to take. And so if we run this, what happens? Sure enough, we get 314A and 1 out of that. Now, it's not necessarily in order because the my dictionary is a kind of a hashed object, and so it's only going to go based on those keys, and the keys aren't necessarily in there in any particular order. It's just going to find the key. And so when we actually look at my dictionary.keys, what happens there? My dictionary.keys, it's actually going to return the keys in the order K2, K3, K1 for that. And so we're not necessarily going to get the same order that we would have in the other objects. It's not really ordered in a way. It is just kind of a hashed object, and whatever we get in that particular order, that's what we get. So that's kind of an important thing to remember with dictionaries, that there's not necessarily an order related to them. And so that kind of maybe gives us a hint for when we want to use the dictionaries in what kind of structures we happen to be doing. Now, another object that we have that produces a sequence of integers. So quite often we want just integers that we are indexing over. And so the method that's going to do that is the range. And so what happens, the range will take the form of a starting value, an ending value, and then how big a step size that we actually want through those values. So if we would put in a range from I to j, then it's going to start at I plus 1, I plus 2, all the way up to 1 less than the value where we tell it to end. And so what happens there, if we would put in range 4, we're going to get a sequence of integers. We're going to get 4 integers, 0, 1, 2, and 3. And so that's going to be how the range works. That's going to be an important thing. We're going to get a lot of mileage out of that function, and let's see how that's going to happen. Let's see how that works in action in just a little bit. Now, when it comes to logicals and comparisons, Python has some built-in values already there for us. So Python has built-in constants of being true and false. Python also has logical operators that we can use, and if we're familiar from our maybe our beginning class on proofs, we remember things like and, or, and not. And these behave in Python exactly as you think that they should. And one thing to remember, do you remember your truth tables way back from your first proofs class? Just to refresh your memory, maybe, that P and Q will give you values of true only when P is true and Q is true. P or Q will be true anytime at least one of them is going to be true, and if P is true, then not P is false, and if P is false, then not P is going to be true. And so we've got all of these kind of logical operators that we can apply in our comparison statements. Now, our comparison operators in Python are probably familiar if you've had any other programming class kind of in your life. The equal to is just, the symbol is just going to be 2 equal symbols. If we only have one equal symbol, remember that's going to be an assignment operator. And so we need 2 equal symbols. That's our comparison. Is it not equal? We put the exclamation point in front of the equal sign. Greater than, less than, greater than or equal to. So we have the greater than symbol and then the equal followed by the equal sign. Less than or equal to, the less than symbol followed by the equal sign. So those will maybe be familiar from any other previous programming classes. And we can say, well, what things can we actually compare? Well, can we compare strings? Yes, we can. Can we compare integers? Absolutely. And can we compare floating point numbers? Yes, we can. And so for floating point numbers, probably here's a good place to give a warning of comparing equality with floating point numbers can be a dangerous thing. And so if we're comparing equality, we should probably try to find a way to compare with either greater than or equal to, less than or equal to, or greater than or less than in that case. So comparing equality with floating point numbers, probably something to avoid. Kind of the floating points are weird things, and I'll refer you back to the video on floating point numbers for that one. Now, the syntax that we have in Python for a conditional statement will just be the if, and then whatever our comparison operation is going to be. So if this comparison operation results in a true value, then kind of like the for loops, we've got this colon here telling us now is the start of the loop. For all of the commands contained in the if statement, we have those indented in. And when we have a command that's outside the if statement, we go back and we get rid of the indentation. And so it's a little bit like the for loop for that one. Syntax is a lot the same. And so we have if whatever thing isn't true in here, then we'll execute this command, then we'll execute another command, and then we'll leave the if then. If we were in a situation where this comparison operation were not true, then we would skip this command, skip another command, and go to the command immediately outside of the conditional loop.